Next up, we have talking about the Internet of Things and the values for highways, Alastair McMahon, Head of Analytics at O2.
Afternoon, everybody. So today I want to talk a bit about the Internet of Moving Things and what that means from a telco's perspective. So first of all, one of the most important slides is that when we're looking at the data of the Internet of Moving Things, we're specifically handling anonymized feeds of data. So we have to do that to comply with GDPR and data privacy requirements. And when we're outputting insights for the customers that we work with, not only will it be anonymized, it will be aggregated as well. So you'll all know O2 as a brand, the UK brand of Telefonica. We provide connectivity services, obviously. And the team that I work in handles insights projects. So this is really about the data that comes from across the network, and we turn that then into mobility insights. So the kinds of data that we're handling, you can divide it up into three types. We have macro data, behavioral data, and in-venue data. The macro data comes from the use of your mobile phones. So when you're making a phone call or you're sending a text message, it creates a time and a location stamp. When you're moving from one cell area to another cell area, as you might be sitting on the train and going in and out of signal as well, you'll create more data events. And those data events together generate about 5 billion network events for us every day. And we have to make sense of those network events to build insights for the types of projects that we work on. Then we have behavioral data, and that's derived from the web logs and the apps that people have on their phones. And again, that's all at an anonymized and aggregated level. So we're not interested in understanding what Mr. Smith is doing with his phone and what website specifically he's visited. We're interested in this proportion of people have these categories of interest, like photography or transport or connected autonomous vehicles, for example. We then fuse that data together with the macro data so we can develop an understanding of the mobility patterns of the population as well as the interest profile of the population. And then where we want to understand more granular insights, say at a building scale like this, or a transport hub, for example, we might then deploy IoT devices to try and understand something about the catchment of that particular building. So where are people traveling from before they get to a particular location? This is particularly popular with retailers. So in high street locations, they'll deploy some of these IoT devices in their stores to understand the catchment of the store, the frequency of the visits, how long people spend in store, and whether they're male or female, what age they are as well. So there's two kind of levels of insight. There's macro insights that are very powerful for understanding the broader population movement across larger areas, and then the micro, what's going on in venue, in transport hubs, for example. So that data together that we collect for 26.5 million customers, if you include our GIF-GAF data set as well, that's 32 million customers, and that's pretty much representative in terms of the population as a whole. We capture about 30% typically of a local population. So it's a robust sample base, and it's currently used in a lot of different transport projects, particularly around transport planning, but increasingly in operational planning as well, and operational response. So the data comes through to us in real time from the network team in an anonymized format, as I've explained, and the challenge for us is then to make that data available to people who want to use it in real time or in batched historical chunks. So at the moment it's available in batches, and retrospective data we can then make available in the form of, for example, origin destination matrices or catchment models, and that would take then a number of weeks to process that and pass it over. But from early next year, we'll be making those types of data sets, those historical data sets, available through APIs immediately. And then probably halfway through the year next year, we'll make real-time data events available to people to support operational use cases. So some of the types of insights we can derive from that data include an understanding of the modes of transport that people use to get from A to B, the points of interest, so where their home location is and where their work location is, and we figure out that from where a phone dwells overnight, where a phone dwells during the day. We can allocate points of interest as home and work locations. If we're studying the catchment of a particular train station or a particular shopping centre, we can then develop further points of interest and understand the travel patterns around those. The routes that people take to go from A to B, so we've got a routing model where we can look at the most probable route that somebody took and correspond the events that are created along those journeys to try and put some accuracy behind which particular route they took on a journey. And then taken together, we'll put all of that into large origin destination matrix, which can be segmented by lots of different parameters, and then make that available typically in large Excel files that people then drop into transport models. But increasingly it's being used for other things. So we're looking at connected autonomous vehicles projects, aviation, sports facilities, what's the use of green space, air pollution, and how that relates to mobility patterns. So we take that location data, and then if we combine it with the profile of customers, it then produces quite a powerful overview of what's going on a network and who's using that network. So one of the things we don't throw away in the anonymization process is age and the type of mobile phone that somebody has. So everything else, though, on this slide, we have to derive from what the data's telling us. So as I've said, home and work location, that's pretty straightforward. Spend power is an algorithm we've built which is derived from where people go on holiday and how often they go on a holiday, where they live and where they work, and that spend profile is spend power algorithm is people's propensity to spend money. So it's not a measure of wealth, so it's therefore different from a lot of for example, Experian type outputs that you might get. It's more a measure of how willing somebody is to spend money. So retailers use that. Transport providers would use that data as well to try and understand potential market share in a particular catchment. For example, with train operating companies, they would use that to understand the potential market share they could capture if they're bidding for a new franchise. The regular routes, as I've explained, that's something that we can figure out. And then in terms of the interest, in terms of media that people consume, the websites and apps that they use and the interests and hobbies that they might have, that's all derived from what the weblogs are telling us. One of the projects that we're probably most well known for in this space is the Highways England Trip Information System. That's available for people to use for transport planning purposes. Highways England use this data set now for pretty much all of their planning projects. That's a 12-month chunk of data, soon to be refreshed with 2019 data, and we developed that in partnership with Jacobs, and that's available now for local authorities to use and other transport planning organisations. And also doing a lot more work around the prediction of impact and the assessment of impact around major infrastructure development. So if you're planning a new route for light rail, or if you're developing a bypass, we're looking at the data now to show what the potential impact of a project might be, and then monitoring post-implementation what the actual impact of that project is. And increasingly, the data is getting used for mobility as a service investigation. So you might want to try and understand a particular location and look at all the modes and the routes and the frequency of trips, and then figure out where potential demand might come from for you to deploy a particular service. So that's increasingly being used for mobility as a service type projects. And then last thing I want to say is around innovation. So it's very difficult to keep up with this sector and how fast moving it is. So we have a program called the Wire Intelligent Mobility Accelerator, which is located at the Transport Systems Catapult in Milton Keynes. And every 6 months, we support 6 organisations into that program, or between 6 and 10 organisations. Some of them are here today, organisations like Valoran and Synaptive. And what that's designed to do is it allows us to set challenges with corporate partners like Network Rail, Stagecoach, Ferrovial, and startup community responds to those challenges. And in response to those challenges, we can then, for example, get access to new forms of data or improve our own products in terms of innovation and improving the functionality of what we do. And it's a partnership approach, so we'll work with them with our existing customer base, introduce them to our customer base, and it gives them exposure to the transport market or smart cities market. But it also allows us to keep in touch with the latest developments. So we have an intelligent mobility catapult, or intelligent mobility accelerator at Transport Systems Catapult, an artificial intelligence accelerator at the University of Edinburgh, and a cybersecurity program at GCHQ. And through all of those, we're able to work with some very interesting organisations. So if you're interested in finding out a bit more about that or anything else that I've just talked about, we'll be on stand H6 for the rest of the day, so you can come and find us there. Thanks very much.